So far when I've done a lot of these recordings, I've just left it up to you guys to just read the notes and then we start the examples all together. Because literally, what I told you guys in class is that when I wrote these notes, it was intentional to everything that I would normally would say or everything that I would normally write down on the board, you've got in these notes. So these are really, really great notes. But as me being the wonderful teacher that I am, I want to take 2 seconds and actually describe, and kind of walk you through these notes, okay? And this is all about developing the inverse functions. We like before we learned the log function and we learned the inverse was the exponential function, or we learned the exponential function and its inverse was the log, or we did the same thing with square roots and quadratic graphs, okay? Well, let's learn about how we can get the inverses for cosine and sine, and tangent as well. If we look at the graph for y equals cosine x, okay, and we look at that, we're like, wait, an inverse can't exist unless it passes the horizontal line test. And if I draw a horizontal line across this graph, it's crossing more than one time. So we're like, how can cosine ever have an inverse button? So if you pull out your calculator, if y'all have it right there next to you or happen to have it nearby, pull out that calculator, and right behind that cosine button, don't you see the words? It's like, this is the cosine button, and right up here behind it, you have this button. It's like, how can that part right there exist when you look at this graph and go, wait, it doesn't pass a horizontal line test? How can the inverse exist? Well, that's what this whole lesson's all about. Okay, and what it basically says is kind of like what we did with the parabola. When you had the parabola, in order for the inverse to exist, what we did is we cut off half of it, and we said, oh, let's only focus it from here to here, and then we can find the inverse. And that's exactly what we're going to be doing here with the cosine and sine graphs and tangents, okay? And what's proper, or what's known to do, is that when you're given the cosine graph, how we're going to shrink it down, what do we decide? Do we chop off the left? Do we chop off the right? What is common terms, or common to math world, is the fact of we chop it down to where we're only in the interval from 0 to pi. And that's what I drew right here. I drew just the cosine graph that goes from 0 to pi. And I kind of opened up the window, kind of narrowed it in a little bit. And then, like I said, right here, notice this new notation. When we take the regular cosine graph and we shrink it down to specifically just from 0 to 5, we call it capital C, capital cosine x, okay? So if you ever see capital C, what it means is you're taking your cosine x and only graphing from 0 to pi, all right? And now that we have it from 0 to pi, which has both positive values because we're above the x-axis, and it has negative values because we're below the x-axis, we kind of encompass several things there, so we want both positives and negatives, so it's a good interval for us to work with. And now that and then for sure, passes that horizontal line test, nothing's going to cross it more than once. And now that we have that, we can actually get the inverse. And like normal, to get the inverse, all we have to do is swap those x and y values around. So look, the x values right here are now my y values there, and my y values are now my x values. And then when you graph these coordinates over here on this graph, then you actually get your inverse function. Okay, and I want you to take 2 seconds real quick. Graph, look at these points. Go over there on the left and find 1, 0. Go over there on the left and find 0 pi over 2. And then find negative 1 pi. Okay, so pause the video, take 2 seconds, because trust me, it is really weird when all of a sudden you're graphing on your y-axis with the pi and the pi over 2's and stuff. It's really, really weird. So y'all take 2 seconds. And then other than that, just noticing the notation. Capital C, because we shrunk our graph, and then we did the inverse, so that's why the inverse right there, okay? And realizing that whether I use this notation, which is cosine inverse, or I write the words arc cosine, they are synonymous with each other. Arc cosine and cosine inverse are the exact same thing. Okay, so let's take the same kind of concept and let's go to our sine graph. Here is the entire sine graph, going for several revolutions, okay? Obviously it doesn't pass the horizontal line test, and we want to narrow it down. Well, we can't just narrow it to 0 to pi like we did with cosine, because that still wouldn't pass the horizontal line test. So what's common in the world of math is actually what's known that most everybody does is we truncate it from negative pi over 2 to positive pi over 2. So again, we get some positive values, we get some negative values, and we pass the horizontal line test everywhere in this little realm. So what I did here was I kind of zoomed in on that portion, going from a negative pi over 2 to a positive pi over 2, and look at my new notation. Now it's a capital S. Okay. And from there, all you did to get the actual inverse one, or the arc sine, so sine inverse, arc sine, cosine inverse, arc cosine, you just swap the x values and the y values in your t-chart. So again, take 2 seconds, pretend like I wanted you to graph these 3 points, and go find them over there on that left graph, and see how weird it is to graph the pi's on your y-axis. And thirdly, if we look at the tangent graph, this little sucker 100% is not passing the horizontal line test. And so what we narrow it down to so it that involves both positive and negative values, is this window right here. It's going from a negative pi over 2 to pi over 2. Okay, here's a big difference. If y'all follow me just real quick, come back up here. With the sine graph, we did or equal to. We can actually equal pi over 2 and negative pi over 2. So we can kind of go from this dot up to that dot inclusive. But when we get to tangent, notice we don't have the or equal to parts. Well, the reason why we can't is because we got asymptotes at exactly pi over 2 and negative pi over 2. So we're just going to go just right up to negative pi over 2 and just right up to pi over 2, but not actually equal to those. Okay, so some points I want you to. So we're basically shrinking the window down to this curve that fits right in between those two vertical asymptotes, and that's what we're focusing on. So what I did was, since we're focusing on this special curve from negative pi over 2 to pi over 2, we're now calling it a capital T, and then we're going to take all of the x values, let me come back just a second, all those x values are now going to be the y values, and all those y values in that window are going to be the x values. And so instead of graphing between vertical asymptotes, when you swap them around, those vertical asymptotes that used to be x equals negative pi over 2's and x equals pi over 2's, remember we swatched our variables, so now they're y equal pi over 2's, and coming down a little bit, you'll see the y equals negative pi over 2. Okay? And same notation, tan inverse or arctan, same way. So I gave you guys just a general summary that the inverse cosine functions defined from the window 0 to pi, inclusive, because we have brackets. The sine inverse or the arc sine one is negative pi over 2 to pi over 2, also inclusive. And then your tan inverse or your arctan is the same thing as the sine, except it's not inclusive. We can't, because of the asymptotes, we can't exactly equal pi over 2 and negative pi over 2. Okay, so let's start with our first example. What we want to do is, without calculator, we want to find sine inverse of pi over 2, or square root of 2 over 2. So what this means is, sometimes what I do is, I know that sine inverse is only defined from, here's positive pi over 2, and there's negative pi over 2. So from here to here, on that unit circle, okay, so from pi over 2, let's say pi over 4, 0, right here is not 7 pi over 4, it's a negative pi over 4. And then down here is a negative pi over 2, okay? So from pi over 2 to negative pi over 2, where do I have a value of square root of 2 over 2? Well, y values are only positive up in quadrant 1, so that means the answer is just going to be pi over 4. Okay? Now the question, if I changed it around and I said, when is sine going to be a negative square root of 2 over 2? Okay? So on this window from pi over 2 down to negative pi over 2, I have a y value of the negative square root of 2 over 2, and you can't say 7 pi over 4, it's only at negative pi over 4. Okay? So if you said 7 pi over 4, it is completely wrong, because the window for sine only goes from pi over 4 to negative pi over 4. I mean pi over 2 to negative pi over 2. Alright, with arc cosine, let's think. Cosine is defined from 0 over to pi. So here my answers could be something like 0. It could be pi over 6, pi over 4, pi over 3, pi over 2, and then here we keep on going on. 2 pi over 3, 3 pi over 4. I'm kind of writing this sloppy, but y'all can all see. It's our typical ones, all the way over to pi. Okay, so what this is saying is, when do I have an x value of the square root of 3 over 2? Well, that only happens from 0 to pi, only at pi over 6. When am I going to have an x value of negative square root of 3 over 2? So only in this window, it's going to happen at 5 pi over 6. All right, tangent. Again, tangents, just like sine, it's only defined up here from pi over 2, can't include it though, down to a negative pi over 2. So if you want me to write out the potential answers for tangent or for sine are only going to be these dots right here. So that is a pi over 3, a pi over 4, a pi over 6, a 0, a negative pi over 6, a negative pi over 4, a negative pi over 3, or a negative pi over 2. So if you don't see, in other words, to answer these questions right here, these three in particular we're about to get to, your answer could literally be only one of these numbers. If it's not one of these numbers, you're not giving me the right answer. Okay, you kind of get an idea of how to work with this one. The inverse function is just a little bit different, but okay, let's go with the easiest one. When is arctan equal to 0? Okay, remember tangent is still, it's like sine over cosine. So for this to equal 0, it's basically is when does sine equal 0? Well, the y value is only 0 in this window at 0. So the answer is 0, or if you want to write it using radians, you can say 0 pi. Okay. If I said, oh gosh, well, we'll come into another one of these just in a second. How about when is tangent equal to the square root of 3 in this window? Okay, well, I've got options. Tangent, again, is sine over cosine, so it's either going to happen at this coordinate or it's going to happen at this coordinate. Oops. So which of those pairings, by the time I do y divided by x, will give me the square root of 3? It's looking like it's coming from here. So if I do this y value divided by or multiplied by the reciprocal of the x value, I get my square root of 3. So that coordinate is actually a coordinate of pi over 3. So the answer is pi over 3. And then if it's negative, it's going to be a negative pi over 3. And that's the answers for those three. Okay? I guess if I wanted to come back up here to sine, if I said find sine inverse of 1, okay, so the y value of 1 is only at pi over 2. Sine inverse of negative 1 on this interval is negative pi over 2. And that's the only answer. Okay, let's get a little more practice in there. So let's keep going down to example number 2. This time we're going to use a calculator. And the key with the calculator is these really are like some of the simplest examples you could possibly do. Just making sure that when you type this in, for one thing, your calculators are in radians, because we're going to give all our answers in terms of radians. And then since you're going with the inverse buttons, that you just hit second sine, second cosine, and second tangent. So with this first example on part A, like I said, the first thing I look at is I go to my calculator and say, okay, it tells me I'm doing radians. That's great. And then I type in the decimal, so 0.8076, hit my second button and sine, so that way it says sine inverse, and I get a 0.94007. Okay, that'll work for me. And that's literally all we have to do for this. If we go down to the next one, at the negative 0.7776, so we're going to go in 0.7776 in our calculators, make sure it's negative, and then hit second and cosine inverse, and I get 2.4616. Okay, and arctangent, so type in 0.4466 in your calculator and hit second tangent, and I get a 0.4200 as my answer. And that's all we have to do with those.